Okay, thank you for attending. My name is Chris Williams. I am the Global Director of Professional Services for APM, Asset Performance Management at AspenTech. A little bit about me, I have been in the space more or less for 20 years. I've worked at IBM on the Watson program before it became a product. I've spent time in the Middle East and in Central Asia with different companies looking at technology, communications, infrastructure, as well as, fortunately, landing at AspenTech and working on predictive analytics, machine learning, and artificial intelligence. I spent 4 years in the Marine Corps. I loved it, but wanted to make sure that I was being kept up to date with the latest technology. So I did my 4, and then I did some reserve duty, and then entered the workforce. Went to the University of Texas at Austin, studied physics and philosophy. My parents thought I'd never get a job. I fortunately have had a few, but that's a bit about me. I'm a father of 4 children, and I've been married for 20 years. Today, we're actually going to talk about the realities of implementations of AI and machine learning and predictive analytics and predictive maintenance technologies from the field, okay? And we're going to get to the actual concrete examples where we're actually talking about the value and the times and the costs. But I would like to start this presentation today, this workshop, by identifying 4 key components. The first component is that we want to make sure that the technology that we implement keeps our people safe. Instead of rushing into danger or rushing to do a repair, we want to give them time to plan, and not just singularly plan, collectively plan as a group across the different disciplines. The second thing that we want to make sure that in that planning and in that execution of the maintenance tasks, that we are very focused on protecting the environment. That is, doing a stitch in time saves 9, as Benjamin Franklin would say, in terms of our maintenance activity. Are we doing the right things at the right time early enough that we don't have to do major repairs and improvements on a consistent basis? Are we in firefighting mode 24/7? The third point that I would like to focus on, obviously, is keeping the assets up and running. Are we improving the way that they operate? Are we improving the way that we operate? And then lastly, are we fast and are we accurate? So those are the 4 key components that will be reiterated throughout this workshop. And hopefully there will be enough time for questions and whatnot as we go through this. But I want to sync those components in so that when we come across them, that you remember and that they bring you into the kind of this integrated message that we're delivering. So what's keeping us from doing that? What are the challenges that we're facing? You know, the first is unplanned downtime. Well, if it's unplanned and our folks are running to make a repair, we know that it decreases our safety and it increases the emissions, right? So points 1 and 2 right off the bat, right? The casualties that come with rushing into a situation, startups and shutdowns included, as well as emitting greenhouse gases and CO2 emissions. Unplanned downtime is also limiting production, driving higher costs and lowering our margins, right? So that's not new. Again, it's a recursive and almost a residual part of the business that in some cases we plan for, and in some cases we mitigate quite well, but there's a balance. The last is, are we limiting our options in terms of mitigation? Why? Because we are in a process of reaction. Our maintenance tasks are reactionary. Lastly, how do we prioritize our resources? How are we making sure that we have the right people doing the right things at the right time? These are our challenges. And we are taking that as our baseline so that we hit these markers, again, keeping our people safe, protecting the environment, improving the operation of our assets, doing it faster and more accurately. So we have now the opportunity with all these stacks of technologies that we can apply to solve some of these problems. But if the technology is not integrated with our day-to-day business, we're not going to yield the value. So one of the items that we're looking at is, do you have a stack of technology? Do you have a bunch of software or on-control, on-demand systems? And are they just tools? Are they providing little warning of failures? Are you still doing reactive maintenance in spite of buying all of these tools? Do you have high spares inventory? Is there safety decreases? Are your people operating safely? Are you reducing your emissions or are they increased? What's the net of all the tools you've bought and all the money you've spent, right? Well, there's a value generator. APM can come in and say, well, if you integrate both the technology and the business, what's going to happen? There's time to plan. We call them failures, but there's also process anomalies that occur. Are we optimizing our schedule? Are we improving the safety? Are we lowering emissions? Have we found new ways of running our business? Answer can be yes. There's opportunities there, but are we taking them? Do we have the time to fill in the gaps that these technologies and these processes yield? So, little factoid. Flared natural gas produces more than 300 million tons of carbon dioxide emissions every year. It's the equivalent of approximately 77 million cars driving over your head every year, just from flaring. This is during our transient operations, startups and shutdowns, right? This is where these opportunities occur. And we wanted to point this out because these are one of the major impacts to our day-to-day operations. We know we're shutting down, we know we're starting up, and we know we're having to contend with the amount of CO2, right? Sustainability is popular, but is an ever-going, ever-continuing effort for us in order to save the planet. From a California refinery event, just as another proof point, we have here over 2 years, you see the numbers, there were emissions from this refinery. And in 1 year, sulfur dioxide was released, and it over doubled over the past 2 years the amount of impact. So now the question becomes, that wasn't a part of the plan. This was just something that happened, right? We were surprised. Mother Nature was a part of the process, and yet we somehow failed to contain what was going to happen. The plan was in place. The execution, even with all the technology, brought us to a point where we still had an event. Again, process safety incidents, startups and shutdowns, 5 times more often to have some type of casualty, right? 5 times. We have people coming into work every day. They want to do their jobs. They want to, have their lunch, enjoy it, go home and see their families. And, we are in a hurry. I'm from the Houston, Texas area. We've got a lot of folks that are in the oil and gas field, and, that's a concern. Planned maintenance improves safety. I mean, this is a kind of a normal thought process that if most of your work is planned and you're not in firefighting mode, you are going to have less incidents. The other side of that is if you have less planned work, you're going to have more incidents. Again, folks are rushing to solve a problem. They're grabbing parts and spares out of the warehouse. There's also an easy KPI to know if you're making a difference. How much break-in work do you have against your planned maintenance schedules, right? Am I spending as much time trying to firefight as I am planning? John Campbell has these 2 diagrams, which I think are fantastic. One is there a risk? Is there recklessness, right? Am I doing something I think is risky? Or am I doing it because, just go do it, go take care of that, right? Are we following the lockout, tagout procedures? Is our O&M up to date? Do we have greenhorns or new people that really understand why the culture of safety is so important? Have we brought that into their marrow? Or are we just reacting to the charge of the day? And we see here that the further we move to the right, the higher the exposure, And this is a continuum. It's not like once we've solved the problem, it's solved forever. It is a culture and a continuance of improvement, of adjusting to the different processes and the technologies that you've already put in place. What if we knew? What if we knew ahead of time, right? What actions would we take? What remediations would we plan for? What people would we staff? How much time is needed? What if we knew? What if we turned unplanned downtime into something planned, right? What if all of the disciplines within our plant, planning, scheduling, production, feedstocks, maintenance, inventory, sales, what if they were all working cross-functionally to achieve the goal, right? It starts with providing the time to collaborate. So yesterday was the 7-year anniversary of my mother surviving breast cancer. And thank you. She told me that early detection, right? You've all heard it. Early detection is why she's still with us. The combination of doctors and specialists that understand the root cause of the problem came together and came up with a plan specific to her that solved it. So now she's going to my son's plays and football games and things like that. It's not different. Back to our tenets at the beginning of the workshop. Are we improving our assets' availability? Are we being healthy? Are we reducing our impact on planet Earth? And are we increasing the safety of our people? Are we doing it rapidly and accurately, right? That's our effort. And regardless of what company you work for, whether you are a competitor to AspenTech or not, we are all collectively moving in that direction for the collective goodness of everybody involved. I think we can say that confidently, and we endeavor to reach those goals. So moving a little more tactically, okay? Saying, okay, Chris, that's great. That's good. Good to hear about your mom, but how are we going to get there? Okay, so I buy into the premise, but how? You're right. I've got a bunch of technology. What's the next step? Well, you've seen the PNF curve, and if you haven't, this is the PNF curve. The problem to failure, where you have 100% production at P and 0 production at F, okay? It's a short lead time. When your control systems are alarming and they're giving you an amber light, the damage is already incurred. The reduction of that asset's life has been impacted. But what if, through actual technologies combined with your business process, you could increase your lead time to failure, your mean time to repair, real KPIs that you use every day, and you could actually see the break-in work drop. You start moving your planned maintenance so that your people have more time to cross-collaborate, understand the root cause, and take the right action that solves a problem. What if then, on that one piece of equipment, I'm also looking across multiple pieces of equipment and processes that are upstream of the one piece of equipment that I'm looking at? And I'm being agnostic because this paradigm works for a lot of different markets around the world and a lot of different pieces of equipment and processes. If I could tell you that I have a tank that has a valve, it's a leaky valve, and I have a compressor downstream of that tank, and I didn't have a sensor. My suggestion to you was, neighbor, friend, I think it's a good idea that we put a sensor on that valve. Well, I know we've had a tough time keeping this compressor up and running, but what if we put a sensor on that valve? Stitching time saves 9, right? Small action, small cost. We put the sensor in, lo and behold, we actually can see suppressor differential on either side of that valve, contributing to liquid carryover, which is the reason you're getting the high vibration. But what if I saw that way upstream? I'm not even looking at the compressor, I'm looking at the tank. Now I can put tons of time between my next maintenance of that particular compressor. You see? So this is how we tactically start moving forward. Data is the new oil, and we have to gather and harvest as much of that information as possible. So, okay, great, I'm on board, P&F curve, need data, how do we do it? My guys have real work. I have IT guys who are just trying to keep the IT and OT infrastructures in place. Who's going to get all the data? Who's going to harvest it? How do we cleanse it? How do we organize it? And then how do we shape it so that it's valuable? Well, our AspenTech solutions streamline the selection and preparation of the data builds. We use AI. We harvest your data. Some of it's coming from your databases. Some of it's coming from other systems. Some of it is coming from operator walkarounds. Maybe it's coming from a LIMS system that you have or a water management system. It's coming from all over the place. We call that the wild. The data is out there. It's in various formats. Some of it's good, some of it's not. Some of it's in an Access database from 1998. True story. So how do I actually get that information? Well, our systems, they select the minimum set of sensors. So we're not looking at everything. We're looking at those things germane to the particular failure or the particular operation or operating state, the regions to be trained and tested on, and the frequency of data needed for analysis. The AI is helping us farm, manage, mold, and shape that data so that it's germane and it's useful. Okay, so that's great. So now you've got a process for bringing in the data and shaping it. Okay, good. Now my guys can keep working. What's the next step? Who is going to actually do it? Data scientists? I've only got a couple of those, and I've got process engineers, and they need to have some input on that. So we call this democratizing AI. Democratizing the process of not keeping it in the hands of one or two types of disciplines, but across the spectrum, back to collaboration, back to my mom, right? Finding the solution in the root cause by having different viewpoints, walking around the problem, identifying it, and then coming up with a way to execute it, right? Start with your plant data. It's high volume, it's high moving. You've got vibration systems that are capturing these sub-second behaviors, different types of IT that you have in place, that stack of technology that we talked about at the beginning. And then we bring it into this middle layer, this automation layer, where our process engineers, your operations folks and your maintenance folks are working together, looking at this and the outputs from it, leading us to an enriched data, something valuable, something that we can use, something we can plan for, okay? Once we've done that, and I think this is really kind of the highlight, it's the integration of all of that work with your domain expertise. My kids ask me, they go, Dad, do you work for Skynet? Are you building the Terminator? Right? No, I'm not building the Terminator. Why? Because human beings are required for this to be successful. The data is what it is, and the process is even as great as our technology is, it requires deep domain expertise, people that know what they're doing outside of the technology, integrated in the business flow to yield an outcome, right? To change the way and new ways of looking at and viewing business without hiring a bunch of new folks, using the people that you have. Why? Because we've democratized the technology and we're able to bring those individuals into the solution, right? The agents that we have inside of our tech are deep learning. They can find the pattern, they can track and trace that pattern, and then look at other patterns, almost like in a fractal. As you get deeper into it, the earlier you're going to detect. When you buy a refrigerator, I use a refrigerator because I have this problem, it hums perfectly. The condenser turns on, turns off, no problem. Put your hand on it, and you feel if everything's working, it's great. Fast forward 5 years, every time that condenser shuts off, the whole thing shakes, right? But you didn't feel that the first couple of years. It happens subtly. But the agents are looking deep at those waveforms, and they're identifying those patterns. They're matching them, and they're saying, you don't think there's a problem now, but I'm telling you, in a couple of months, couple of weeks, you're going to have an issue. Come see me, and let's see what the problem is. That's what our technology does. We go from time to value improvement as well as cost to value improvement, right? We want to reduce your time from the time that you've purchased the solution to the time that it's implemented and you're seeing benefit. Okay, so Here's the flight plan that we go through just to kind of button up this portion of the tactical work process. We're going from your sources of data. We're bringing it in for cleansing, for association and organization and extraction. We're doing some hyperparameter optimization. Hyperparameter optimization is there's subtleties depending on your process. It could be something that's batch, or it could be something that's continuous. You might be a pharmaceutical company. Perhaps you're a pulp and paper company or a metals and mining company. There are excursions that are very specific to your business. We take it and we account for those. Then we build our first pass of agents. Agents are the technology that we deploy like little bots, and we cast them across your process units, and we let them begin the learning process. We take some of your legacy data, we process it through the agents, and then, let me use my pointer here. And then here is where the machine learning kicks in the AI at this point, right? Now in that learning process. And the ensemble of metadata, that's back to the upstream process, where I'm not just looking at the asset, I'm also looking at the assets around the assets, the contributors to the failure in the first place. We have to account for them. So we build the ensemble and then we deploy. And what you'll see down here are some of the case studies. I'll work this way backwards. Cyclone in cement. You know, customer comes to us and says, I've got a problem with my cyclones. That's a very unique use case. We're able to find the failure patterns. Wind farms, turbines and electrical, and we'll get into some of the deep data pieces here, and clogging of wells, right? Where you're doing scraping to get the aggregate off. You might have to go hot diesel, right? So these are some of the use cases that are outside of the compressors and pumps that you may have been used to hearing or seeing. These are the other things that we're looking at. So let's just take a step deeper into these use cases. In one case, we were able to increase the time between the scrape events, and that's where you're getting all this yucky stuff out of there, by 2.5 weeks, 2 to 5 weeks, sorry. The prescriptive guidance leading you users to, sorry, I don't have my glasses on, leading the users to plan the difference between hot, crude, and diesel flushes, right? So they normally go through, and this is a manual cleaning process. Whereas when you give them the time, they can actually plan and get the right supplies in place and then run the flush activity. Our agents on the wind farm provided 4 to 6 months of early warning for gear failure on the wind turbines. Prescriptive guidance leading to users-driven intervention plans like gear oil replacement and electrical subsystem repair. I'm just going to pause there too, because wind farms actually are, in terms of process safety and people safety, you know, the engineers have to climb up these things, and they're 100, 200 feet sometimes, and the turbine is on the outside. So they have to climb the pole and then hang out the back, and they're very proficient and very good. But around 2011, 2012, when the wind farm kind of boom began, there were risks, lots of casualties on the maintenance of the wind farms. And so our 4 to 6 months of early time actually helped them move the preventative maintenance schedules, okay? And then here, as we talked about, blockages in the cyclone in the cement plant provided the guidance on the feed composition and the kiln operating conditions, sorry. And so across these 3 use cases, all right, these are different use cases across, you know, different parts of the world, different assets, that shows that we are fast and accurate, right? Our deployments don't take years to get done. This is not, oh, sign us up, this will be a 3-year deployment. I mean, it can be depending on how much you sign us up for, but typically this takes months for us to get from the purchase of the software to your value proposition on why you bought it in the first place. Okay? Moving on to case studies. We're going to give you 4 or 5 examples of where this was done, completed successfully, and the positive impact. So we caught a recip failure, reciprocating compressor failure. The traditional method of using PV charts, we don't, we've gone away from that using our technology. What did we see? Starting in late April, a series of alerts were generated on the compressor, late April. 30 days later, during May 6th, the repair on one of the cylinders, a clogged lube oil pump was found. So it took 30 days for someone to take action. And again, kind of going back to when you get the prescriptive portion of the prescriptive technology, it asks that you yield the advantage of the early warning by taking action. You can wait 30 days, and in this case, that's 30 days of more clogging on the lube oil pump, or you can take the alert and you can react quickly, and it reduces the amount of maintenance that's required. We have prevented more severe damage on 3 additional cylinders by taking an early action. That's on a reciprocating compressor. Catching small failures before they become catastrophic. Again, stitching time saves 9. Starting in late April, one of our agents alerted on the primary crusher, indicating that position B was abnormally high. On May 14th, again, roughly a month later, an inspection found that the hydraulic line was found to have had a leak in it. So now, what did they do? Well, more severe damage to the crusher, potentially to the bush bearing, was avoided, all by replacing a line, right? So let's say that you have pieces of equipment that are not heavily sensored. We have a situation with a conveyor. So starting in mid-April, an agent alerted on the discharge conveyor after the primary crusher. This indicated that the currents for the 3 drive motors were out of synchronization. So we only had a few sensors, right, looking at those motors for the crushers. When we expected, we found an oil imbalance in the motor gearbox, and it was corrected. This avoided the gearbox failure and potentially coupling failures as well, okay? But this allowed time for the maintenance team to get together, build a plan, react to the alert, and yield the value. This is one of my favorite slides in the whole workshop, right? Moving the risk profile before where our customer was placing the amount of actions and needs of that particular asset, the reformer, and moving it to here, right? What are we looking at? We're looking at the reformer consequence. The shutdown and significant downtime. Impact on personnel safety was highly significant, right? Impact on the environment, significant. Impact on reliability, productivity, and financials. mtel actively protects the asset, avoiding downtime, which would result in 7 days of lost production. So that's just one example of what happens when you deploy the agents on a single piece of equipment. And the safety of our people and the planning of our actions and the execution of those maintenance tasks after the alert is where the value is. And then over time, this happens, right? If I'm doing the same things the same way, even with the technology that I purchase, I'm not changing anything. I'm still in my red risk profile. I have to take and yield the action, okay? Here in the oil and gas industry, we had a challenge, right? It was part of a corporate digitalization initiative. It was effective and efficient asset management. This is what we're going for. This is what the customer wanted. Our solution was predictive maintenance, stabilizer column prediction, high sulfur prediction, and recycle compressor failures reduced. Value created, better planning, prevention of unplanned downtime, increased process availability, safeguarding the people and the environment. Metals and mining, right? Improve the availability of the equipment, some hovering around 60%. better management of maintenance spend. Equipment to tell us when to do the maintenance. Our solution, over 1,800 mtel agents across 300 assets, developed and managed by one person. I haven't really talked about the deployability, the enterprise capability of the solution. But you don't need an army of folks when the bots are out there, the agents are out there in your enterprise giving you early alerts. They can be managed by a small subset of people we've democratized and trained and enabled to be able to utilize our solutions, right? It's now deployed across an entire business unit. The next question becomes, all right, this was great. I've got a proof point. What else can I keep from failing? How else can I reduce our impact on the environment? How do I keep our people safe in other areas? How do I land, get it proved, and then deploy across hitting these three key components? How do I do it quickly? Petrochemical, reduce the downtime due to fouling. The aim is to give the following insights with predictive model in relation to fouling. Our solution, you're going to get less downtime, energy savings, extended lifetime of the furnace, retention and increasing of the knowledge on how to continue to help keep the furnace up and operating. The depth in which you can monitor your facility will dictate the level of performance you achieve. That's a quote from the customer, right? We avoided 2 days of downtime per year per furnace, up to 1.7 million euro in losses was avoided. Wind farms, we talked about that, but let's go through the details. Sparse failures. I mean, we're talking about, the tilting of the rotors to catch the wind. They're like a fleet of kites, if you will, spinning, being articulated to get the most productivity out of Mother Nature. Maintenance operations constitute 20-25% of the total levelized cost per kilowatt hour, and each failure can cost up to $250,000 to resolve each. Our mtel agents were used and capable of predicting gearbox damage. Another capability is being able to transfer what you've learned from one asset across the fleet. Functionally and fundamentally, in the wind farm itself, these assets behave, for the most part, the same. But we don't have to take each asset and start from scratch. We build a library, and then you transfer that knowledge between the agents, providing you a very deployable enterprise way to get your arms around your fleet. And that's what we did here with the wind farms. 5 turbines exhibit potentially 4 different types of failure: yaw gear in one, low speed in another, intermediate speed, and high speed shaft gear failures, right? What's the value we created? The transferable agent for a predictive maintenance solution for wind turbines. We're very proud of that because it was a new space. Significant reduction in time and effort to create the agents. We thought it was going to take quite a while because this was new for us, but the agents learned very quickly. Working collaboratively with the customer and their deep domain expertise, we were able to get the agents tuned, trained, and deployed. And rapid time to value and scalability because of transfer learning, because we were able to teach each of the agents. In cement, I'm getting a note from the back that I'm being long-winded, so I'll try to hustle. But frequent blockages in the filters of the cyclones, infrequent and unrepresentative hot meal sulfites sampling, and subtle changes in the preheater process that eventually leads to blockages. So our agents are capable of predicting the cyclone blockages. Multivariate models provided guidance to operators to bring the process back to normal, right? So this is kind of real-time feedback. We're giving you a prediction. You're starting to move off the trail, if you will, and we're telling you to get back to normal so you can save the batch. Right. Eliminating just 25% of the blockages generated over $1 million in savings. Early and accurate detection of cyclone blockages helps minimize downtime and optimize the maintenance. So, it's just, story and story after case after case. If I give our people time, if we have time to collectively and collaboratively work together, we can get there using the technology and the business processes together. On the refineries and pipelines, we reduced the safety and environmental behaviors of a customer. We deployed our solution to 150 compressors, pumps, blowers, and other key assets across 6 different sites in 15 months. Deployed, done. Actually, in this project, that expansion into other areas is ongoing. From the chief digital officer of that company, our solution mtel is a rock star. I was giggling because I kind of walked through this in front of my kids, and my little 8-year-old gave me the air guitar. Right? So it was kind of cute. So $2 million saved thus far, and we're still in the process. Right? So the 4 things that we talked about exemplified over one common denominator, and that's time. How are we safe? Give our people time. How are we greener? We don't impact the environment because we're not in a rush. We're not breaching the assets. They're not leaking. They're not doing the things that they've done in the past, not as often, because we're taking our time and we're yielding the action from the early alerts. They're running longer. They're running faster because we are accurate and able to deploy quickly. I would just say that, again, that we are all on the same journey to provide these key components to our customers, to our colleagues. I think the federated we here, I think we all collectively agree on that, and those are our goals. I will open it for questions. Do I have time? Ma'am? 3 minutes? So whoever raises their hand first gets the question. The key differentiators between the offerings and the companies, I would say that, again, I think we're all trying to achieve the same thing. We want to maximize our productivity, we want to keep our people safe, we want to save the environment. I think there's different ways and different plans on executing that mission, but I think the destination is the same. So what are the advantages? In our case at AspenTech, we have an agent technology, and we just went through how we go about incorporating that speed to deployment, the quick learnings of those agents, the adaptability across markets and asset types. I think that once you focus on one piece of equipment and realize that I can land and expand and cover hundreds of pieces of equipment in a very short amount of time, let's go. Let's get that done so I can move on to other projects so that we can, like we said earlier, this is not just put the technology out there and stop. It is a cultural and behavioral shift moving forward where the stovepipes and the partitions drop, we work collaboratively, and we yield the experience from our techs. So I don't know if I exactly answered your question, but I think we're all headed to the same goal. Okay. Any other questions? Yes, it was a very starchy lunch. Ma'am, were you stretching? Oh, yes. Okay, good.
No, you presented a lot of good examples of the challenges and then the benefits. But what I didn't hear was, what is mtel? Like, what is the underlying technology? Is it a neural network? Is it PCA? Is it GBT? What is it?
It is a neural network. Yes. Yes, it is a neural network with a deep belief system, right? So those agents, once trained, there's a lot of, you'll find a bunch of different algorithms on, social media. I mean, they're all out there. The advantage is that it's prepackaged. I'm not asking a data scientist to get clever, right? This is boxed, ready to go today, right now. And once deployed, really it's collaboration between AspenTech and you so that we can understand the processes, you understand the technology, you'd find out which type of situation you want to apply to which asset. When I'm saying that is, do I want automatic learning agents? Do I want these bots to continually learn? Or am I looking for a specific problem that I'm trying to solve? So there's tuning opportunities and configuration opportunities within the software to match your specific needs. So we don't ignore CBM, for instance. We still have condition-based monitoring alerts. We can build specific rules to get those alerts. And on the other end of the spectrum that we're using for wind farms and others, we have the deeper technology. Did I answer your question? Okay. Anyone else? Ask if you dare. Yes. We have a microphone coming.
Hi, I wanted to understand your, the last case that you had up there with 150 compressors and pumps.
Yes.
I wanted to understand, what the challenges were with false positives, and perhaps more importantly, false negatives that the customer may have faced. With
Yes.
this.
No, it's a great question. So this is where the collaboration comes in. Really spending the time to understand what is a true failure, what is normal, how do you operate the compressor? And I use an analogy of, kind of river streams and stones. A lot of technologies look at the stone, they look at the asset, but really the problem is upstream, and it's happening in a different operating state, right? So you're going to get a vibration, but that's the net effect of all the different operations over the time, right? So we understand from the operations point of view, the reliability point of view, the data scientist point of view, because they're looking at the data every day, and we're coming in as Aspen Tech. We need to spend time with them to understand what they've seen so far, and then shape that data to get to the goal of reducing those false positives and those false negatives. We have what we call a pre-commissioning process that we won't deploy an agent that doesn't have a certain amount of accuracy to it, right? And then an F1, a mathematical F1 score. It gets scored, it's got to be around 95, 96, 97%. Then we can deploy it, and then we'll tune it once it's deployed, because that difference in 3 or 4 points is something operational that's esoteric, that's just hard to capture either in data and operation. And even with someone that's, they're like, oh, well, this is what we've been doing for the past 20 years, and we are tuning these items through the process. So that's how we reduce those failures. But it's not us being smart folks going into a room somewhere. We work collaboratively with our customers to reduce that risk profile. Did I answer your question? Oh, thank you. Anyone else? Thank you very much for spending time with me today, and come see us at our booth number 4 in the general session. Thank you.